is 0 in all the condition, then it is a contradiction. And if the output is mixed, combination of 0 and 1, then it is a contingency. I again repeat, if the output is 1 in all the conditions, then it is a tautology. If the output is 0 in all the conditions, then it is a contingency, then it is a contradiction. And if the output is a combination of 1 and 0, then it is a contingency. Then talking about the different Boolean laws. Different Boolean laws, we have done it already. So for Boolean laws, you need to remember the laws. You need to remember the laws. Then you need to remember the statement. Their statement needs to be clear. And then verification of a Boolean law using truth table. For example, you are given a Boolean law and then you are told to verify. Simplest one, if you talk about the De Morgan's theorem, like if I talk about the De Morgan's theorem, the first statement of the De Morgan's theorem is A plus B bar is equal to A bar dot B bar. Now you are told to verify this using truth table. What we will do, I'll make a truth table A, B, then I get A plus B, then I get A plus B bar, again A bar, this is B bar, this is A bar dot B bar. Now 0, 0, 0, 1, 1, 0, 1, 1. A plus B, it is a OR gate, so 0, 1, 1, 1. A plus B bar, it is 1, 0, 0, 0. A bar, it is 1, 1, 0, 0. B bar, it is 1, 0, 1, 0. A bar dot B bar, this is 1, this is 0, this is 0, this is 0. Now this is the LHS and this is the RHS. LHS is equal to RHS, hence true. So if you have to prove any Boolean expression using truth table, then you can apply this logic to get the truth table and then get the final output. So that will be one condition which you will be using. So this is from proposition part, that you can be asked to write a proposition. You can be asked to convert a proposition to converse, inverse or contrapositive. Then you could also be asked that if there is a proposition given and then if you are asked to get the converse, inverse or contrapositive, or you have to verify it using the truth table. So either of the ways you will be able to get this from your logic. So that is from proposition part. Then when we talk about the logic gates part, logic gates already we have discussed in the previous video about the different logic gates, what are the types of things and the questions you will be getting from the logic gates. So logic gates we will not discuss much from that portion. You could refer to the video today and then you will be clear with that. I'll just once again verify, explain you the. So this will be there in your question number 1. Question number 1, this part will be there, and again max terms, min terms will be there. So if, for example, if you talk about a logic gate part or max term, when you talk about a truth table, max term and min term is used in SOP and max term is used in POS. Min terms, if we talk, for example, if I say F A B C D is equal to sigma 1, 3, 5, 7. Now 1, 3, 5, 7. If I've taken only 3 terms. ABC. F ABC equal to 1, 3 sigma 1, 3, 5, 7. Means if this is the truth table A, B, C, this is F. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now, this we consider, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. 1, 3, 5, 7. So 1, 3, 5, 7, the output will be 1, 1, 1, 1, and 1. The other set will be 0. Right? So this is the truth table. Now if I have to write the min term, so this will be, this is 0, 0, 1. 0 is considered as complement, A bar, B bar, C. Again, this one 0, 1, 1. Then it is A bar, B, C. Then again 5, 1, 0, 1. A, B bar, C. 7, A, B, C. So this is again So this is when we talk about the SOP expression. So we'll write A bar B bar C plus A bar B C plus A B bar C plus A B C. Okay. So this is the SOP expression, right? So when we have to write the sum of product expression, that time we check the values, they will be written as 1. And for getting the min terms, what we do? We take 0 as complement and 1 as non-complement. Because 0 as complement and 1 as non-complement. Next, if we have to write the, this one is clear, I guess. If we have to write the POS expression, for example, again I say 5, 0, 4, 5, 6. 0, 4, 5, 6. Now, when it is product of sum, now for product of sum, what we do? The outputs which are taken here. So this will be all those things 0, 4, 5, 6. So 0 will be having the output 0, 1, 2, 3, 4. 4 will be having the output 0, 5 will be having the output 0, 6. Others are 1. Now, जहां जहां पे 0 आया है, I'll be taking those values 0, 0, 0. In case of POS, POS में क्या होता है? Like 0 is taken as non-complement and 1 is taken as complement. So it is A plus B plus C. Again here, A bar plus B plus C. This one, A bar plus B plus C bar. This one, A bar plus B bar plus C. So what I will write? F is equal to A plus B plus C dot A bar plus B plus C dot A bar plus B plus C bar dot A bar plus B bar plus C. So this is the POS expression. So we can convert the SOP and the POS expression by the help of the statement which is given. So this is about writing SOP and POS expression. I hope this is clear to everyone. This is the cardinal expression and this is the cardinal numbers are there. Okay, this is clear, writing SOP and writing POS part. Okay. Now again, when you talk about, so this is here, and again logic gates is there, that is done. Then solving the K-map. Okay, let me solve the K-map. F A B C D equal to sigma 2, 3, 4, 5, 6, 7, 8, 10, 11. 6, 7, 8, 10, 11. Okay. Now what we do? First we draw this. A bar, B bar. A bar B, AB and AB bar. This side it is C bar, D bar, C bar D, CD and CD bar. Now this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, 8, 9, 10, 11, 12, 13, 14, 15. 2, 3. So it is sigma. So 1, 1, 1, 1, 1, 1, then 8, then 10, then 11. Now in this case, we have this squad, we have this squad, and we have one rolling quad. So what we will do, we will not consider this quad because like if we talk about this quad, so this will be a redundant because all its elements are also members of other groups. So first one will get a quad between, quad 1 is in between 4, 5, 6, 7. So this is now A bar B. We talk about quad 2, which is in between 2, 3, 10, and 11. So this is what? This is from this side B bar is common, and from this side C is common. So B bar C. And then we have a rolling pair between 8 and 10. So this is A, B bar, and C, C bar cancel each other. So D bar is left. So F is equal to A bar B plus B bar C plus A B bar D bar. This will be the final expression, and then you will be making the logic circuit for this. Okay? So I hope this is clear to everyone. Reducing the Boolean expression using a K-map. So that is the for SOP. Similarly, for POS, if we talk about, for POS again, we get the values. There we will be taking the values as 0. जहाँ जो value दिया हुआ है, that we will be taking it as 0. So I take one again, a question I take. For example, I take F ABCD equal to 5, 2, 3, 4, 5, 6, 7, 8, 10, 11. Now what I'll do, that I take this value like this. 2, 3, 1, 2, 3. Now this will be A plus B. This will be A plus B bar. This will be A bar plus B bar. This will be A bar plus B. Similarly, C plus D, C plus D bar, C bar plus D bar, and C bar plus D. Now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 2, 3. So 0, 0, 0, 0, 0, 0, 8, 10, and 11. So what will happen? Again, I'll make this group, I'll make this group, and I'll take this pair. Now it is a POS, so it is between 4, 5, 6, 7. This is the quad. So this is A plus B bar. Now this quad again, a quad between 2, 3, 10, 11. This is what here? 2, 3. So this is A and A bar cancel each other. So B plus this side we have C bar. Then again a pair between 8 and 10. This is A bar plus B plus D. So my F becomes equal to A plus B bar dot B plus C bar dot A bar plus B plus D. So this is the K-map using POS form. Now when we talk about the POS and SOP, so this is clear. Next thing which comes is again a question in which the scenario is given or the different conditions are given. So always remember, based on the conditions which are given, we will make the truth table. Truth table में ये कभी फर्क नहीं पड़ता है कि whether it is a SOP or POS. The truth table will be like the same. Means we have 4 statements. For example, if I say in the first condition is that A is big, A should be high, B should be high, and C should be high. So we get those output as 1. Again, the second condition and the third condition. So depending on the conditions, first we will make the truth table. Truth table does not know, or truth table doesn't bother whether the question has told you to find the SOP or find the POS. once the truth table is made, because the truth table is very important. If the truth table is wrong, whatever you do further, that doesn't has any value, doesn't have any importance. So first we will make the truth table correctly. Once the truth table is correct, then depending on what is told in the question, if the question has told to reduce it using SOP, so SOP ke liye we will consider the 1 as the output, or 1 as the value, which has those are conditions where the output is 1. Those will be taken in the K map. And if the question has told to solve it using POS, then जहां जहां पे zero आया था वो values लेंगे, and then we will make the K map using POS. Once it is done, then we will reduce, then we will draw the logic circuit. So this will be your question where you will be solving the SOP and the POS, and then the third one in that is where you are solving the question or making the truth table. Based on the truth table, you are making the SOP or the POS expression. Based on that, you are making the K map, you are reducing the K map, and then you are finally getting the reduced expression, make the logic circuit for that. So this is a question of 10 marks, so that will be there. One more question in this section, in which you get 2 or 3 or 4 or 5 questions depending on the marks distribution. In that you can get various questions from the application of logic circuits. Encoder kya hota hai, decoder kya hota hai, difference between half adder and full adder. Those parts will be again discussed later on. So you just need to revise the application of logic gates. Application of logic gates. Then you also need to understand the various laws. Then you need to be aware of making different logic circuits. Verification, verifying or proof of logic circuits statements using reducing the values. So that will be there in this part. So that is part 2, section A, where we will be getting the various questions from Boolean algebra. 2 questions where there is a use of K map, that is SOP and POS. Then again 1 question, and then again the mixture of questions. There will be 3 or 4 questions depending on that. So that is part 2, section A. Now when we talk about section B may out of 3 you will have to attempt 2 questions. The first question which will be there, which can be there, that will be using it. There will be involvement of 3 things here. One is array, one is string, and the one is various loops or number system type questions. In either of the questions, I mean, maximum of the questions will be involving multiple functions, right? Maximum of the question, all the 3 near about, they will be involving multiple functions where the class is defined, right? Class will be defined, functions will be defined. It might contain in 1 or 2 questions, might be constructors are there. So if the constructor is there, what is the condition for a constructor? The name of the constructor should be same as that of the class name. तो कंस्ट्रक्टर अगर डिफाइन किया हुआ तो कंस्ट्रक्टर हमको यूज करना है. Question may, if the class names are specified, right? If the class names are specified, then it's compulsory that you use the same class name and the same function name as is given in the question. You must, for part 2, section B, you must make the variable description table, or you should write the comments. For every methods, you must write the comment. So writing of the comments is needed compulsory there, or you may write the variable description, both will work. Once this is done, then you can start again with the once this is done, we will be again discussing the different parts. So this is basically when you are taking these programs. And next thing is, once it is done, then you will be getting this part. Second question of array. Array, if it is there, if it is an array based question, then you will be getting single dimension array or double dimension array. Again, functions will be defined, functions will be specified. You need to use those functions and draw the program or define the program accordingly. Second part is again, in this question, you can get 1 question where there is the use of object creations. So it will define the function, create objects, multiple objects. There can be 1 function which is asking for the object creating. 1 function can be there that where you are linking the various objects. So the object will be passed as parameter, right? The object will be passed as parameter, and from that object you will be getting the values, right? From that object you will be getting the values, and those values will be used in the program. So those values have to be taken care of when you are writing the programs, when you are attempting the programs. Then the passing on of objects. Like we say, for example, I take a question that in which there is 1 program which has 2 objects. one function which is having the parameters as the objects, and then those objects will be passed as parameter when we are using in our program. So that has to be taken care of, and those objects will again be passed as parameter when you are using, and those parameters will be passed. So if I say ob1 comma ob2, so ob1 is the first object, ob2 is the second object, and when those objects ob1 comma ob2, for example, the parameter contains object, and then we pass the object. So the first object and the second object, they will be having, for example, I'm saying ob1.x. So that will be containing the values of x, that is for the object 1. So all the programs which we have done for object creation, you practice those programs, that will be there. One question must be there which will be involving the object creation and passing on of objects. Next, when we talk about the second thing, that is part C, right? Again, part 2, section A, section B and section C. Now section C, there will be 3 questions जिसमें से कि 2 program attempt करना है. The first one, either it will be from stack or queue, right? Stack or queue will be there, so that in this programs you have to just mention the function, whichever function it is asked, or whatever functions it can be. For example, if it is a queue, then it could be that removing element or adding element, which stack if it is, then push operation or pop operation, that will be there. So that stack program, always remember the stack pointer keeps a note of the function. Stack pointer keeps a note of the position of the element. If it is adding an element, push operation, then first what we will do? We will check whether it is pointing to the stack pointer or not. If it is pointing to the stack pointer, means it is the last element and no more element can be added. So it is a stack overflow situation. And then if it is not, then we will increase the stack pointer by 1 and then we will add that element. If it is a pop operation, we will check whether it is null. If it is null, then no element can be added to it, and it will be a stack underflow situation. Otherwise, we will remove the element, then decrease the stack pointer by 1. That is in case of a push and pop operation of a stack. Next, when we talk about queue, again the similar thing. We can add and remove elements from the different ends. Queue, the element will be added at the rear end and the element will be removed from the front end. So accordingly, we will look for the pointers and then we'll be adding or removing the elements. If it is a circular queue or D queue, there are different situations. Third, we have the tree. The question can be tree, from tree where we need to basically it will be accessing the different elements of the tree in order, pre-order and post-order traversal. That will be there. Then you can get again, so 3 marks question can be from the tree operation. Then there can be question from complexity. Complexity, as we had discussed, that a complexity, what is complexity? Complexity basically defines that what are the different ways through which the element or the program specification can be managed. That depends on time complexity and memory complexity. Okay, space and memory. When we are talking about the elements, the program's efficiency, as much less memory it consumes, that is a better thing. Complexity can be of 3 types: best case, worst case, average case. So for different operations or different applications, we have different types of complexities: best case, worst case and average case. That table is there. You need to go through the table and understand the complexity of those elements. Again, if we talk about elements when we are in a complexity, what is ON? Means it is depends on directly ON square. That depends on the square. Log N, again it is the depends on the square root. So different types of complexities can be there. From stack, again you can get questions for infix, prefix and postfix. Like if I say, if I have a statement, if we have A divided by B plus C divided by D, and we have to obtain the postfix operation of or postfix expression for this. So first we will solve the bracket. This is AB division plus C D division. Now this is one expression, this is one expression. So again postfix AB plus C D division and plus. Right? So this is the postfix expression for A, B and division, C, D, division and then plus. So this way we can convert a infix expression to a postfix expression. Infix, the operator is in between. Prefix, the operator is before, and postfix, the operator is after the operands. So that is basically when we talk about this part. Yeah, one question will be from section C. There will be one question from inheritance. Inheritance, again, the superclass will already be defined. You have to make the subclass. The subclass is needed and the main function is needed. You do not need to specify, or you do not need to define the superclass. You do not need to define the main function, right? So the superclass is already given. So we will start with the class. Subclass extends superclass. If there is a constructor in the superclass and we want to call it, we will be using the super keyword to call the constructor of the subclass. If there is a function with the same name in the superclass and in the subclass, then in that case, again, we will be calling, for example, there is a function named display in the superclass. There is a function named display in the subclass as well. So when you are calling the subclass function, you will be using the function when you are making a void display in the subclass. Again, so first it will be super.display. So what it will do, it will call the display function from the superclass. Again, if there is a constructor both in the superclass and in the subclass, then in that case, what we will do, when we are defining the constructor of the subclass, first we will write super. So what it will do, it will call the constructor of the superclass, and then the constructor of the subclass will be called. So that is there. Anybody has any doubts? Anybody has any doubts? You can unmute yourself. Today, due to the restrictions, I could not conduct it live on YouTube. From next classes, whenever we have, so I will be conducting it live on YouTube as well. Free question. Okay. This meeting will end after 1 minute. I will again schedule one meeting and share the link. Okay. Super class is base class. Subclass is the child class. I'll again schedule a meeting. Okay. Let me see if it extends. I don't think it will extend. If it extends, then again, I'll just wait. Any other doubt? You could just post in the chat. So